For 100 years, black holes have been a symbol of cosmic mystery, a puzzle on the brink of human understanding. How can an object that emits no light emit jets of energy greater than those produced by billions of stars? It's a question that has puzzled physicists since Einstein first outlined black holes in his theory of general relativity. Today, after a century of puzzlement, scientists are finally getting closer to an answer. After years of puzzlement, scientists have finally discovered the secret behind the mysterious power of black holes. Instead of relying solely on their rapid rotation, they have discovered that a natural process called magnetic reconnection helps generate the enormous energy that erupts from them in jets that extend thousands of light years into space. This discovery transforms our understanding of how black holes work and their role in shaping the galaxies around them. A team of astronomers and theoretical physicists at Goethe University Frankfurt has revealed an unprecedented discovery that redefines the way we understand black holes. The study, published in the Astrophysical Journal Letters, focused on the famous black hole M87 star, the first black hole imaged in 2019 by the Event Horizon Telescope. According to the team's findings, the secret behind the cosmic behemoth's immense energy release lies not only in its prodigious rotation, but also in a remarkable process known as magnetic reconnection. At the heart of the mystery, M87 is located in the Virgo galaxy, 55 million light-years from Earth. It is one of the most massive black holes known, with a mass equivalent to 6.5 billion solar masses. Although its gravity is so intense that even light cannot escape, it emits jets of matter thousands of light-years long, moving at speeds approaching the speed of light. This paradox has puzzled scientists for decades. How can something that swallows everything around it simultaneously release such enormous energy? In the past, the prevailing explanation was the Blandford-Zernick mechanism, which postulates that the magnetic field surrounding a rotating black hole can extract some of its rotational energy and convert it into radiant energy in jets of matter. However, this explanation remained incomplete. Modern simulations were unable to account for some of the mysterious properties of these jets, particularly their brightness and tremendous acceleration. The invisible explosion. This is where the German team began their research. The scientists used a sophisticated computer tool they developed themselves known as the Frankfurt Particle and Cell Code for Black Hole Spacetime (FPIC), a simulation system capable of representing the behavior of charged particles and electromagnetic fields near the event horizon with unprecedented accuracy, according to Daily Galaxy. Through this simulation, the researchers observed a fascinating phenomenon. Magnetic field lines were breaking and reconnecting in a recurring pattern, releasing enormous amounts of energy. This process is known in physics as magnetic reconnection, the same phenomenon that causes solar flares on the surface of the sun, but here it occurs in an environment billions of times more violent. Our results open up a revolutionary possibility that the Blandford-Zernick mechanism is not the only one responsible for generating energy in black holes, but that a second process is operating alongside it: magnetic reconnection. Together, the two create the extraordinary power we see in cosmic jets, says Dr. Filippo Camelloni, one of the researchers. Energy is born from chaos. Simulations showed that near the equatorial plane of a black hole, magnetic field lines interact violently to produce bubbles of high-density plasma called plasmoids. These bubbles accelerate to nearly the speed of light and are ejected outward, forming the initial nucleus of jets that extend across space. Dr. Luciano Risola, the research team leader, explains, "Thanks to advanced simulations, we were able to see how a portion of the black hole's rotational energy is extracted and converted into radiant and material energy. This process explains the extreme brightness of active galactic nuclei and the acceleration of particles to relativistic speeds. In this sense, a black hole is not just a graveyard for light, as we previously imagined. It is also a cosmic superengine that converts gravity and magnetism into pure energy, in a physical cycle that almost defies human intuition. The universe redistributes its energy. What makes this discovery even more significant is that it is not limited to M87 star alone. The phenomenon of magnetic reconnection may explain the behavior of many other cosmic objects, such as neutron stars, magnetars, and even active galaxies' galactic nuclei. AGNs, which are among the brightest objects in the universe. These cosmic jets don't stay within the confines of the black hole. They extend out into space, influencing the evolution of the galaxies themselves. The energy and matter ejected by these jets redistribute gas and dust in the galaxy, affecting the formation of new stars and the evolutionary path of galaxies over billions of years. A team member says in a side note, "When we understand how black holes generate their energy, we don't just study just one object. We're studying the energy cycle of the entire universe." A new chapter in understanding the universe. This research reflects a radical shift in the way scientists approach extreme cosmic phenomena. In the past, black holes were viewed as terminal regions, where matter and light ended. Today, they are considered natural laboratories of extreme energy, revealing new physics at the frontiers of human understanding. As supercomputer capabilities improve, more complex simulations could reveal additional details about the particle dynamics and magnetic fields at the heart of these cosmic monsters. Perhaps in the coming decades, we will be able to understand not only how energy is emitted from them, but how it can affect the fabric of the universe itself. Dr. Rizzola concludes, each new discovery makes us realize that black holes are not the ends, but the beginnings of a deeper understanding of nature. They are not voids that swallow light, but factories of knowledge and energy at the same time. After 100 years of questions that have baffled minds, scientists have today succeeded in uncovering one of the greatest secrets of the universe, that the energy emanating from the heart of darkness is not an eternal mystery, but rather the result of an astonishing interaction between gravity and magnetism in the harshest environment known to science. With this, scientists have not only solved the mystery of the black hole, but have also taken a step toward understanding how the universe itself works, from the depths of darkness to the most distant stars of light.